Bismillahirrahmanirrahim. Assalamualaikum and a very good day to Madam Mastura and everyone. Today we will be presenting our group project for topic 2, Correlation and Regression General Outline, with the title Data of Blood Donation in Melaka. Before we begin, let me introduce our group members. I'm Nurul Batrisha binti Anwar. This is Nur Bahia binti Muhammad Daud, Nurul Atira binti Osman, Nur Alia Sofia binti Muhammad Tarmizi, and Nurul Najwa binti Muhammad Ibrahim. Now let's move to the introduction. So let's begin with a brief introduction. So what is blood donation? Blood donation is a voluntary procedure where a person donates their blood to help the others. The main goal is to ensure that hospital and healthcare centers always have enough blood for a patient who need transfusions, whether it's due to surgeries, accidents, or chronic illness. Blood donation is also critical in emergency situations and for treatments like cancer care or trauma management. Now let's move to the problem statement. Although blood donation is essential for our healthcare system, the rate of donation can change over time. Even though Melaka is known to have one of the highest donor rates in Malaysia, we are unsure whether this trend has remained consistent throughout the years. It's possible that factors like population changes or major events such as the COVID-19 pandemic have influenced these patterns. So, through this study, we aim to analyze the trends and data of blood donation in Melaka from the year 2018 to 2024 and observe if there is any correlation with external factors.
Assalamualaikum, I am Nur Bahia and I will explain about the objectives of this study on the relationship between population size in thousand and the total number of blood donations in Melaka. First and foremost, the objective is to investigate the relationship between the population size and the total number of blood donations in Melaka. This means we are exploring if changes the population data in thousand are linked to changes in how many people donate blood across different years, which is from 2017 until 2023. The second objective is to determine whether an increase in population can predict an increase in blood donations. Here, we aim to understand whether the population growth leads to a higher number of blood donations or if other factors may play a more important role. We will be using scalar plot graph to check consistent patterns to show strength, strong or weak, the trend, positive or negative, and the shape, linear or non-linear. Last but not least is to develop a regression model to predict future blood donations based on population trends. Due to our topic chosen, which is topic 2, correlation and regression, we will be using linear regression to forecast future blood donation numbers using historical population data. This will help health agencies estimate future blood supply needs by looking at how the population is expected to grow.
Assalamualaikum and hi everyone. Moving on to the next slide, which is the data collection and scatter plot. This slide presents data on blood donations in Melaka from 2017 to 2023. On the left side, we have a table showing the population in thousands and the number of blood donations for each year. Over this 7-year period, the population steadily increased from 888,000 in 2017 to 936,000 in 2023. However, the number of blood donations shows a declining trend, dropping from 9,387 in 2017 to 6,022 in 2023. In this analysis, population is treated as the independent variable, while blood donations are the dependent variable. This means we are examining how changes in population might influence blood donations rates. The scatter plot on the right visualizes this relationship. The blue crosses represent actual data points, and the red line is the regression line. As shown, there is a strong negative correlation, meaning that as the population increases, blood donations tend to decrease. This trend raises important questions about public health engagement and awareness, which we'll explore further in the next slides. That's all for me. Thank you.
Assalamualaikum and hello everyone. For this part of the presentation, I'll be explaining the value of art and how we interpret it based on the data given. So, we use the Pearson's product moment correlation coefficient formula, which measures the strength and direction of the linear relationship between two variables, which in this case, population and blood donation. After substituting all the values into the formula and calculating it step by step, we got R equals to negative 0.85, which research shows a strong negative correlation. What does this mean? It means that when one variable increases, the other tends to decrease. So that means as the population increases, the blood donation decreases. Thus, there is a strong negative correlation between population and blood donation. So in short, the value of R equals to negative 0.85 tells us that there is a consistent and strong inverse relationship between the two variables. Next, we'll look at the coefficient of determination or COD. Starting with point 1, the relationship of population and blood donation is R equals to negative 0.85, then R squared equals negative 0.85 squared times 100%, which gives us 72.3%. This calculation gives us the COD, which tells us the proportion of explained variation in the dependent variable, in this case population, that can be explained by the independent variable, which is blood donation. By squaring the correlation value and multiplying it by 100, we find that 72.3% of the total variation in population is explained by blood donation. Now for point 2, this means that only 72.3% of the variation of the population is due to the blood donation, while another 72.7% is due to other factors. In other words, although a large part of the changes in population can be explained by blood donation, the remaining 72.7% of variation is caused by other factors that are not included in this analysis, such as birth and death rates, migration, access to the healthcare, or general living conditions. This shows that while there is a strong relationship, it is not perfect, which is common in real data. So the coefficient of determination helps us understand how strong and how reliable that relationship is based on how much variation is actually explained.
Next, I will continue to the next slide, which is prediction example using the equation of regression line. And the equation of regression line is y equals to bx plus a. And in order to get the y value, we have to calculate b first and then a. And the formula of b is written at the right side. You can see the b formula, and we just substitute what we get earlier into the formula of b, and we calculate and we get negative 75.11. Yeah, and then we get the value of b. We can calculate the value of a using the formula of a as written at the below, and we calculate, we substitute the value of b into the formula, and we get 75736.14. And then we have the a and b's value. We can substitute into the formula of regression line, and the final equation we will get is y equals to 75736.14 minus 75.11x. Next, we can predict the blood donation in Melaka using the equation of regression line that we get earlier. So let's say there are 900,000 populations, and we just substitute into the equation and we get y equals to 8137.14. Therefore, if the population reaches 900,000, there will be approximately 8,137.14 blood donation in Melaka. And when in the interpretation is when the population is increasing by 1,000 of people, then the number of blood donations in Melaka will be decreasing by 75.11. That's all from me. Thank you.
And my name is Nurul Najwa. I am the last member of this group, and I will be explaining about the conclusion and the future work for this study. So based on analysis of data from 2017 to 2023, so this study concludes that there is a strong negative correlation between population growth and blood donation in Melaka. So contrary to initial expectations, so the result showed that as the population increased, the number of blood donation declined significantly. So in this study, we found that the correlation coefficient approximately is about negative 0.85, and the coefficient of determination has the value of 72.3%, indicate that population changes account for a large proportion of the variation in blood donation. So these findings suggest that other underlying factors such as public health issues, reduced awareness, or accessibility to blood donation campaign may have contributed to the declining trend. So an interesting finding in this study is that based on the data collection, we can see that the most drastic decline in blood donation occurred during 2020 and 2021, which aligns with the peak of the COVID-19 pandemic. So this indicates that public health emergency can have a substantial impact on voluntary blood donation activities, likely due to movement restriction, fear of infection, or cancellation of donation drives. So this study also highlights the need for greater efforts to understand and address the barriers to blood donation despite an increasing population. So for future research, it is recommended to include additional variables such as the number of blood donation, the number of blood donation drives, public awareness campaigns, age distribution of the population, and eligibility criteria for donors to gain a more comprehensive understanding of the trend. So expanding the study to include data from other states or a longer time period could help determine whether this is a local issue or part of a broader national pattern. And additionally, incorporating qualitative data such as surveys or interviews could provide insight into public attitudes toward blood donation. Using a multivariable regression model may also improve the accuracy of future predictions and support better planning for blood donation initiatives. So that's all from me. Thank you.